Good morning once again and welcome back to our class in Mechanics of Deformable Bodies. And on our previous topic, we have tackled about statically indeterminate axially loaded members. And you already knew what are statically indeterminate axially loaded members and how to solve those kind of problems. And now, let's tackle another kind of topic, which is your thermal stress. So, as you all know, when a body is subjected to a change in temperature, if that change in temperature is increasing, what will happen to your body? We all know that your body will increase its size, right? If the temperature is increasing. But if the temperature is decreasing, what will happen? Then that material will contract, right? So, asa man dira ang thermal stress? Thermal stress occurs when, look at this kind of situation. When you have this beam, and there is a change in temperature from T1 to T2, so nag-increase ang temperature. Okay? Nag-increase ang temperature, and this beam here tends to increase its size. Okay? Because of the increase in temperature, ni-increase ang iyang size. But since this beam is fixed, supported on both ends, then bisag nag-increase ang iyang size, di siya ka-increase sa iyang size tungod kay nakasupport siya at both ends. And therefore, instead of increasing its size, nag-create na lang siya og stress sa iya sulod. Okay? And that is what you call your thermal stress. Okay? So take note, thermal stress only occurs when an object is trying to increase its dimension, increase or decrease its dimension, but it cannot do it because it is constrained at both of its ends. Okay? So, mo na itong gitawag nga thermal stress. We have an equation sa atong thermal stress. And this is our general equation to solve for your change in temperature to the change in the deformation of your material. Okay? So, the deformation of your material due to thermal stress is equal to your coefficient of thermal expansion, which is your alpha, multiplied by the change in temperature multiplied by the original length of the material. Okay, so take note, the deformation of your material due to thermal expansion is just equal to the coefficient of thermal expansion multiplied by the change in temperature multiplied by the length. In your metric, your length has a unit of meter siguro probably. For your delta T, you have a unit of degrees Celsius. And for your alpha, it usually has a unit of 1 per degree Celsius. Okay? So, makancel ni siya and then mabilin kay ang length. Gana lang. Okay. So, let's have an example. Okay, let's have this example. So, we have these 3 posts nga nag-support aning atong rigid nga beam. Okay? And kani atong rigid beam, na subject siya of a distributed load of 150 kilonewtons per meter. Okay? And we have to determine the force supported by each beam. So, unsa ang force nga naa sa each beam? So, ang atong ipangita is to look for the forces, internal forces of each beam after the temperature is raised from 20 degrees Celsius to 80 degrees Celsius. Okay? So, mo na atong goal. Mutang free body diagram sa atong beam. And instead of putting this one, ato ni siya i-resultant. 150 kilonewton per meter times 150 times 0.6 meters. So this is 90 kilonewtons. And you have here your FST, FST, and your F aluminum. Now, so ito yung nabaton, use your equilibrium equations. Summation of forces along the x, wala kay x kay wala x component, so y ta. Going up equals to 2F steel plus F aluminum minus 90 kilonewtons equals to 0. Okay, padayon ta. So, what will happen? Okay. So, dili ta magamit og moment karon because there is a deformation due to the change in temperature. Okay? So, kanilang ato magamit for this kind of equation. This is your first equation. Now, what will happen to the loadings after you apply this 150 kilonewton per meter nga load and your change in temperature? Sa relationship sa deformation sa atong steel ug aluminum. Since this symmetric man sila, steel sa isig ka end and aluminum sa tunga, and then ang imong load is distributed, so we can say this ang deformation aning tulo are equal. So, your deformation of your steel is equal to the deformation of your aluminum in this case. This is your steel. This is your aluminum. Okay, ako na nagitapad. Ang imong steel ug aluminum, na subject siya into change in temperature. So therefore, nag-increase na ang length sa atong steel ug sa atong aluminum. And I will call this deformation as your delta T sa imong steel and this one as delta T sa imong aluminum. Sa pag-change in temperature pa lang ni. Pero, naapatay, giingon nga, na-force nga gi-apply. So, ato ingon, nga minaog siya at this level. And kanipod siya, minaog at this level. And kani nga change, ato na gitawag as delta F of your steel. And this one is the delta F of your aluminum. And since we know your delta steel is equal to delta aluminum, then ang imong delta ST ato sa unahang delta ST. Di ba kay mao man ning delta ST? Delta steel. Mao delta steel and then mao ning delta aluminum. Di ba kay equal man na sila duha? Kay equal naman na sila og length pag una unya equal sila og final nga length. Okay. So, therefore, una ta sa pag-change niya sa temperature. Positive siya kay ni increase ang iyang length, so delta T ST sunod minus your delta force of your steel is equal to delta temperature of your aluminum minus the delta force of your aluminum. Okay. So now we have this one. So ato na ipangbutang kaning mga values ani nila. So this is your temperature. So therefore this is ito to. Ito formula ni. Alpha still times change in temperature times length of steel. Sunod, minus F steel times L steel over area steel multiplied by modulus of elasticity equals to aluminum, change in temperature, length of aluminum minus F aluminum, L aluminum over area aluminum times aluminum. Oh, ito ipangbutang ang values. My goodness. Ito lang i-red kayo. Nipis-nipis magagi ang red. So this is for your steel 12 times 10 to the power of negative 6 per degree Celsius times 80 degrees Celsius minus 20 degrees Celsius times 250 millimeters minus Takibaw, F steel times length sa steel 250 millimeters over cross-sectional area of pi times 20 millimeters squared times 200 kilonewtons per millimeter squared. Ito, okay, sakto. So, sa imong aluminum, 23 times 10 to the power of negative 6 per degree Celsius multiplied by the change in temperature which is 60 degrees Celsius. Diretso lang nako times 250 millimeters. Sunod, minus F aluminum multiplied by 250 millimeters over pi times 30 millimeters squared times 73.1 kilonewtons per millimeter squared. So long. So after some intensive solving sa kaninga mga values, so ako nagi-cut ng video ha kay malangan. So ako nagi butang nga values and then ani ni siya and then we arrived on our second equation. So this is our second equation and finally using your two equations, two unknowns nga knowledge in using your calculator, you will arrive that your answers on your FST will be negative 16.4 kilonewtons. And for your F aluminum, your answer is 123 kilonewtons. Okay? So, ngano nga atong steel kay negative man? Okay, so your steel is negative since it is subjected to tension. Okay, so tension ni ang atong steel, niinat ang atong steel. Ang atong aluminum is positive since ni-compress ang atong steel. Okay? Ay ang atong aluminum since ni-compress ang atong aluminum. Okay? So this is your final answer sa atong problem. So yun na. Okay. So there are more problems on your modules, on your PDF copies, and you may study it there. And since taas naman ka itong lecture karon, so it is good for you to practice some other problems. Okay? So as a summary for this lesson, we have talked about the thermal stresses and we have another equation for your displacement and your temperature change relationship, which is your delta T is equal to your coefficient of thermal expansion multiplied by the change in temperature and multiplied by the original length of the material. Okay? So, and we also have solved one problem in regards to thermal stresses. And again, if you want to practice more, there are a lot of sample problems given on your modules or on some other references. So, if you don't have any other questions, so this topic right here is related sa imong statically indeterminate axially loaded members nga problem. Ang imong gyapon button is just to look for the compatibility equation. And now, in this case, na-appeal na ang atong temperature change. So, ang imong button is to imagine how the material deforms once it is subjected to loads and it is subjected to a temperature change. Okay? So, ingana lang ang atong topic karon. Nagtikalison atong topic, right? And it is better for you to study harder. Okay? So, if you don't have any other questions, then study this one for this week and see you again for our next class. Bye!